So yesterday we have seen polymorphism, upcasting and downcasting, and also somewhat abstraction, partial abstraction we have seen. Okay, but again we have to discuss this. So before discussing abstraction, so we have one more concept, access modifiers. Okay, access modifiers. What is meaning of access modifier? What is the meaning of access modifier? So whenever you are providing the access to your class, providing the access to your class. Providing the access means suppose somebody wants to use your logics, use your class logics or data which you declared inside the class. Okay, you should not allow everyone. You should not allow everyone to access your class or everything to access. So you have to restrict the data members, and also sometimes you have to restrict your logics as well, some logics as well. Okay, so let me create separate package for the access modifiers. Not class, let me create the package. Access modifiers. Okay, so if you have more than one name, so put it dot. So this is my access modifiers class. Inside that, okay, I create a simple example, the arithmetic operations only. So like your calculator. Okay, the same method I will copy to access modifiers. Okay, so let me close it. What I do is I will rename it to arithmetic operations. So this is one class, right? This is one class. It has some methods. And also I want to create some global variables. Okay, static global variables or final variables. Static final some int a equals to 10. Okay, whenever you are writing some final variable, declare with capital letters. Static members. Int some b equals to some 20. Like that you have some data. Like that you have some data. In your class. Suppose if you are creating some one more class, access arithmetic operations. Access arithmetic operations. Finish it. So if you want to access arithmetic operations in your access arithmetic operations class, what you have to do? So let me create a main method. Okay, there are two ways, right? So those we have seen. Two ways means one is you can directly create the object for your arithmetic operations. Or you can extend the arithmetic operations class, and you can create the object for your child class. Okay, so let me create one more class, extend arithmetic operations. Extend arithmetic operations. These two ways you can access, right? If you want to access some class information, some other class information. So either you have to create the object for separate object for other class, or you can extend arithmetic operations class here, and you can create a common object for your both parent and child classes. Okay, so if you want to access arithmetic operations with arithmetic operations object, so addition you are able to access. Okay, 10 and 20. Let me access all the methods. Okay, let me subtraction you can access, and also multiplication, and you can also division. Okay, all these are you are able to access. All these are you are able to access. In arithmetic operations, we have 1, 2, 3, 4. Okay, and also you can access final variable and instance data. Final variable, let me create one more. So final variable can be static final variable or instance final variable. But generally instance final variable we won't create because we already assigning the data, right? We already assigning the data. This data won't change in the future. Suppose if you want to change in the future, it won't change because it is a final. When you declare with final, this data won't change. So in that case, maintain in a common memory. Maintain in a common memory. So if you want, you can create as a instance final also. Okay, so let me create B, and let me create static normal variable, and int normal instance variable. Okay, so if you want to access these data, this is also you can access simply. Okay, so let me print those. So what I have to do, so for identification purpose, the output identification purpose. Okay, so what I have to do means, so you can do like this. The result you are printing. Okay, result I am printing. Do not confuse. When you call these methods, these will return some value. Okay, if you observe in the arithmetic operations, so these are returning the values int. And also I will access the global variables which we created just now, final variables and all. Okay, if you want to access, yes, you can access static data. Okay, A, This is a final variable. Okay, so here it is a static, right? So that is the reason it is asking you to use class name. Okay, follow the standard. Why to follow the formal way? So here, if you want to access b value, final b value, which is not a static, so use the object reference. And again, you can access static data, that is C. C is also a static variable, and D is a instance data access with object. D. Now you are able to access everything. Okay, so not only here, if you extend these arithmetic operations class with the child class object, you can also access all these methods. So here the problem is, whoever is extending your class, or whoever is using your class, okay, you already created some logics, so somebody wants to use your class, they have the full control to change the data in your class, this data, if they want, they can change. So you should not allow the users to modify your data. So you have to protect your data first. Then you can give the access. And also you have to protect your logics. You can give the access for usage, but you have to protect your logic. Okay, if you want to perform that, we have access modifiers. Okay, access modifiers. So we have different types of access modifiers. By default, if you don't specify anything, that access we call it as default or package access modifier. Default or package level access modifier. We have protected. Okay, sorry. The very first one is public. If you specify any method or any variable with public keyword, this is also a access modifier. Okay, so your methods, your members, class members, variables and methods access from any package. Okay, if you don't specify anything, it is a package level access. Within the package level access. So we have protected. Okay, so which is, it gives the access to your sub package also. Not sub package, subclass. Whoever is extending, okay, for them it will give the access, subclass level access. We have private, no access. It won't give any access if you declare with private. So we have public, default, protected and private. Okay, if you don't use any keywords, these keywords public, protected, private, which means default. For default we don't have any methods. Sorry, we don't have any keyword. Okay, so how we can use this? So here I have some data. Okay, this data I don't want to share with the others. How I can restrict? Suppose if you make this static variable as private, see, in the arithmetic operations, I mean access arithmetic operations and extend arithmetic operations, you are getting the error. What is this error? The field arithmetic A is not visible, which means in the arithmetic operations with this keyword, you can hide your data. This cannot be accessible by other classes. You can access only within the class. We can access only within the class. Okay. Suppose if you make the addition method as private, again you cannot access. In access arithmetic operations, you are getting error. Here also you are getting error. In arithmetic operations, you are getting error. Again, addition level also you are getting error. Okay. So let me make multiplication also private. So again, multiplication also you cannot access, right? Multiplication, addition, and A values are private. You cannot access in any of the classes except your own class. I don't want to share these logics. I don't want to share my data. In that case, you have to make your variables as private if you don't want to give the access. And also, if you don't want to override, if you don't want to give the override access to your methods, in that case also, you can make your methods or variables as private. So let me create the same method, this method, into access arithmetic modifiers. Okay, so here also access arithmetic modifiers. Okay, here you have addition, and here also you have addition. First of all, okay, so suppose if you create like this, okay, if you are not accessing this one, so anyway, so this notation, even though you create like this, okay, this is up to this particular class only, because you will not get access for your addition method because it is a private method. Even though you create the object, you cannot access. If you are unable to access arithmetic operations class methods, how you will override? Okay, if you access, then you can have a chance to override, but you cannot override. Why here it is giving the not giving the error, which means even though you create addition method, so it acts like this particular class method only. It cannot override the arithmetic operations private method. Okay, so that is one rule. In interviews, they will ask, can we override the private methods? So the answer is you should not say like no. Okay, so the method itself we cannot access in the subclass. How we can override? You have to give the answer like the method itself cannot be accessed in the subclass. That we cannot override. Okay, this is fine. So if you declare with protected, okay, here this is my private, this is my private method. So if I make it as a protected, what happens? So you will not get error for accessing multiplication method. You will not get error for your subclass. Subclass means whatever the class you are using to extend these arithmetic operations. in that class you will not get the error. See, you will not get the error for multiplication. So did I remove private for addition? Okay, so here we have private, that is fine. But why we are not getting error for addition? Okay, this I have to remove. Yeah. See, if you observe here, this multiplication method is a protected method now. Protected method. Protected in parent class. This is private in parent class. This is again private. Okay, if you do this, if you check the same thing in access, if you create a separate object, okay, so here within the package it will give the access. One more thing. Okay, so you will get to know if you access in the other package. Okay, so this is also protected. This is private. This is protected. Okay, in other package we will see the difference. Okay, so protected it will give within the package, it will give the access. Okay, and also I have to mention subclass level access and within the package. Within the package. If you use protected, okay, it is acting like a default. Suppose let me create, okay, let me use arithmetic operations class into polymorphism. Here also we have arithmetic operations. What I do is I will create a separate package. Okay, access modifiers. Okay, we should not create like this. What I have to do is access data access. Okay, data dot access. Data access. Finish it. So here, okay, I want to use these two methods inside this class. The same classes I'm using inside the data access class. Okay, when you use protected, what happens? Let's see. In the other package. See. So it is asking to import it. Okay. Suppose if you create some class, that class is available in some other package. If you want to access in another class, another package class, first you have to import it. Then you can get the access. Okay, let me import it. Okay, so here also, let me import that arithmetic operations class. Yeah, let's see. Okay, so when you use private, you cannot access that private members from the class, even though you extend or don't extend. When you use default, if you don't specify anything, okay, so here division is not specified with any access modifier, and subtraction also not like declared with access modifier. So in this case, you can directly access within this package, up to this package only. Up to this package, you can access. Up to this package, if you create a number of subclasses or a number of sub packages, like if you put access.modifiers dot, if you put some other thing, other package name inside, you can access from the main package to sub level package. You can access default members. Okay, these two are all default. This is also default. Okay, this is private. So this one I make it as a protected. This is protected. Okay, so this one I make it as public, and this is also I will make it as public. So when you make the members as public, let me make it as C. In data access class, you are not able to access subtraction and also division. Okay, let me make it as public, and division also I will make it as public. If you make the methods as public, so in your other package, access arithmetic operations and extend arithmetic operations class, you can access subtraction and division. Subtraction and division. So if you extend the class, you are able to access protected member also in the other package. If you observe here, multiplication is a protected method. Okay, multiplication is a protected method in the arithmetic operations class. So you are able to access when you extend this class, extend your class. But coming to accessing the arithmetic operations, if you create the object for arithmetic operations, you cannot access the multiplication method, even though it has the protected keyword. Okay, other package it won't give the access. Within the package it will give the access, protected, for your subclass and also for your direct object. But coming to other package, the protected keyword won't give the access for direct creation of object. If you extend it, it will give the access. See here, you are able to access multiplication, you are not getting any error. And also private, you cannot access. This is the protected one, again, B. Okay, so B you are able to access. Again, if you go to access arithmetic operations for that B level also, you will get the error. Again, it is a protected in protected in protected in the class. There is no parent, right? So protected in the created object. Protected in the created object. Yeah, this suits. So private in the created object. This is also protected in the created object. Private in the created object. Okay, so these are direct creating the object of a class. So this is extending private in the parent class. So this is protected in the parent class. Protected in the parent class. This is private in the parent class. Okay, so what about subtraction? It is a public. So public in the parent class. Okay, this is also public, right? Public in the parent class. So similarly, so this is also public and this is also public. Okay, so in the access also what you can do. So this is public in the created object. Because after creating the object only you are able to access, right? Public in the created object. So this is also public and this is also public and public. Okay, now what I do is, so here, if you observe here, for all these, you declared with some keyword, right? Some protected public, like that, right? So what I do is, for division, let me remove this public. Let me remove this public. Okay, we have public, protected, private, and what about this? This is a default access modifier. If you don't specify anything, so within this package you can access. Suppose if you go to here, you are able to access the division here for the direct creation of object. If you go to extends, here also you are able to access division. Okay, it is a default method. Default. Okay, so simply what I do is just copy this and go to here. So here the division is a default in the created object, default access. So let me write access also. This is a little bit important. Okay, even though you use or don't use. Okay, so for accessing the class information, some class information, this is important. Okay, you will see the difference between the default and other modifiers. Okay, so here it is a default access in the parent class. So now the division method is a default access, having the default access, because we didn't like declare with any keyword. So if you want to access this method outside of your package, this is the package. Okay, if you expand it, so you can see inside whatever you have. So outside means these all remaining packages are outside packages. All these remaining packages are outside packages. Suppose if you want to access that division method, it won't give you the access. See, it won't give you the access. It is a default access. Default access. Protected also it won't give, and the default also it won't give in the other package. In the other package, default. If you extend also, it won't give. For the default access, protected it will give you the access in the other package, but default it won't give. Default it won't give in the other package. So using these keywords, so we have to protect our data. We have to protect our data and also our logics. Suppose if you don't want to share, you have to protect your members. If you don't want to share your logics, but you have to give the access. Okay, private methods you cannot give the access. Private methods and private members you cannot give the access. So if you want to use within your class, then declare with the private. If you want to give the access to other classes, in that case, you have to choose these public, protected, and default options. Okay. So here what I do, so to remove the errors, what I have to do. So let me comment private members. So this is private and this is outside the package, which means default, and this is also private. So here you have 3. Again, if you come to arithmetic operations, you can see 4 now. 4. Not only 4, 5. Okay, so this is private. Again, this is protected. Default also you cannot access. This one also you cannot access. So this is protected, you cannot access. So here you are able to access protected one. Here this is a protected. You are able to access in the subclass. Okay, similarly, if you come here, so here we have In the access modifier, we have how many comments? 5. In extend operations, how many comments? We have 3. In access modifiers, in access arithmetic operations, 5 comments, and extend we have 3. So if you come here, so you are not able to access addition, and also you are not able to access private variables only you are not able to access. All other you are able to access, right? All other things you are able to access. If you compare outside the package, here you are not able to access 5 values. Those are protected, default, and private. So coming to here, how many you have protected, private, and default? Okay, so this is private 1, this is 2. Okay, 2 private, 1 and 2. 2 protected, 1 default. Those you are not able to access outside of your package. But within the package, protected and default you can access. Okay, so in extend arithmetic operations, so you are not able to access 2, 3 statements, I mean 3 methods along with the variables. So here, if you compare, just only one method you are not able to access. Two members only you are not able to access. The difference, see here 2 and here 3. Okay, here 2 and here 3, and here 2 and here 5. Okay, like that you can protect the data. So generally, once you implement any package, okay, you will share your logics as jar file. Okay, you will share your as jar file. Here, why we are getting this arithmetic operations? What is this? Okay. Okay, so let me remove this. This is fine. Okay, so these modifiers not only for your members. I don't want to share this class outside my package. Outside my package, I don't want to share this class itself. In that case, if you remove the public, that package also you cannot import. See, immediately got the errors. This package also you cannot import. But within the package you can import. Within the package you can create the object within this package. But outside the package, this class cannot be accessed. Okay, but you can specify the main class. You can specify only private and default. If you don't specify, which means default, protected or private, you cannot, protected and private you cannot create for the main block. Suppose if you want to create the protected and private classes, you have to create the classes as inner classes. So I already told you, so inner classes also we can create. Class within a class we can create class, inner class you can create inner class. So for this inner class, so let me create it as a 1. You can give protected if you want, public also you can give. Protected and public and also private. So let me create as public, protected, with the default, and also you can create with the private. Okay, if you don't want to give the access to other packages, your classes to other packages, in that case you can create the default class. Okay, most of the time we create, most of the time we create with the public only, because we will give the access to everyone. Some classes only we won't create. See, this is the private, public, protected, and private. Okay, if you want to create a class with private or protected, so you have to use in the inner classes. Outside classes you cannot use the public and protected and private. Okay, so what is the use of, like, we are just understanding the concept, that is fine. Where I can apply this, where I can apply these logics, where I can apply these access modifiers. So when you start doing the abstraction process, so there we will provide the access modifiers. Okay, for easy understanding of these access modifiers, okay, we have one diagram. So let me show you that for better understanding and to understand, to remember in a easy way. So we have access modifiers. Yeah. Okay, so the first column is modifiers, and the second column onwards, class, package, subclass, global. Class, package, subclass, and global. Okay, global means outside of your project also. Sometimes project to project also we can share the variables. Okay, so that is global packages. Okay, so let's see. So if you create the class, inside that, if you use any modifier, those members are accessible within the class. You can use like anything. Okay, so public you create, protected you create, default you create, or private you create, those can be accessed within the class. Okay, if you use any keyword, those you can directly access within the class. For example, let me create here main method. Okay, so here I do so I create the object for arithmetic operations. For my arithmetic operations, I created the object. So private you can access any modifier. If you use, those all can be accessed. Okay, so within the class. Within the class. So let me replace it. Within the class, you can access any modifier. If you use any modifier, that won't applicable within the class. You can create the object for your classes, inner classes, and you can access everything. Okay, if you use these modifiers, if you are accessing in the package level, so package level except private, all default, protected, and public are accessible. Okay, if you compare with our example, so in the package we have two classes, another two classes. So here you are able to access protected, default, and also public, right? You are not able to access private only. Again, if you extend also, you are not able to access private. Except private, you can access everything again, right? Subclass. Coming to the subclass. Subclass is nothing but if you extend any class, okay, so whatever the class you are using to extend, that class we call it as subclass or child class. Okay, subclass or child class. So within the package, if you create the subclass, again it is comes under package. It is comes under package. Okay, if you create outside the class, if you create outside the class or sorry outside the package, in another package, if you create subclass for your like class, arithmetic operations class, that time protected you can access and public also you can access. Default and private you cannot access. Okay, so here I have extended in another package, so I'm able to, okay, so let me make it as public only this class. Okay, because we should access the content outside of the class, outside of the package. Okay, if you go to extend, here you are able to access, here you are able to access protected and public only. So coming to default and private you cannot access. Default and private. Okay, which giving the meaning default and private it is giving the access. I mean default and private it is not giving the access. Public and protected it is giving the access. Okay, outside the package, okay, if you create outside the package, if you create some other class inside that, if you want to access the arithmetic operations class members, you cannot access private, protected and also default. You can access only public. You can access only public members, only public. Okay, so this is comes under global. Public only you can access, protected, default and private you cannot access. And also, so we can pass our members, class members. If somebody is accessing our class members into some other project. Okay, how we can share our members into other package. Suppose you created this logic, this arithmetic operations logic. How you can share this logic to some other person, some other project member? It is very simple. What you have to do is you have to right click on your package. You will get a option export. Just type for Java, sorry, jar. You can create a jar. Suppose if you want to share or if you want to use some other person's logic, so you have to access as a jar file. You need to include jar files into your project. From that jar, you can access the logics. Okay, so next. So here, what are all the packages you want to export? I want to export only access modifiers. Okay, this class only. I want to yeah. So here class path, all these are not required. Okay. So where you want to store your jar file? I want to store on my desktop. Give the name arithmetic operations. Arithmetic operations. Okay. So here, save it. It will be saving as a arithmetic.jar. Okay. So here, let me do one thing. Go to settings. So nothing is there in the settings. Okay. This entire package. Okay. So here also, I just want to give arithmetic operations. Okay. This class only. Okay. Fine. Okay. Let me finish it. Jar export finished with warning. See details for additional information. That is okay. Okay. You have created the jar file. So where it is? This is the jar file you have created. Arithmetic operations. If somebody wants to use your logics, what are all the logics he can? What are all the logics he can access? What are all the logic he can access? Okay, so let's add this jar file to our project. So let me close all these, close all. So if you want to add some jar file, if you want to use some jar file into your project, simply right click on your project, go to build path. Okay, in this setting you have to go, and here you can see the libraries section. Go to libraries, in the class path, add external jars, click on desktop, arithmetic operations jar, open, apply and close. So now in the reference libraries you have the arithmetic operation jar. Inside that you can see the package. Inside the package you can see the class also. If you want to use this class, okay, what you have to do is, let me create one more okay, let me access in the data access. Class name is access arithmetic operations from jar. Okay, for understanding purpose I'm putting these common names. Okay, so let me create, finish. The similar way, if you want to access the jar file arithmetic operations class. Okay, so just type, see here it is showing when you try to create object arithmetic operations from access modifiers, polymorphism, encapsulation, and also you have some data access, something it is showing. Okay, so which one I need to use? Okay, from if I use from access modifiers. Okay, so here, so for this package also I think access modifiers only. So if I want to use from the jar file, okay, what I have to do? So let me use extend. This is extend arithmetic operations. Okay, what I do is, so I simply change the name as, I simply use the name as calculator. Okay, so here the same package, here also is the same package. It will confuse to get the packages. So when you're creating also, you have to give a proper naming convention. So what I do is, so this is access modifiers, right? So let me again export it, export as a jar file. Okay, here I want to export only access modifiers. Okay, this is fine. Okay, I want to rename the class name. Rename the class name. Arithmetic operations only. I just copy. I just paste here. So some modifier resource must be saved before this operation. Okay, that is fine. So I want to give the name as calculator. Calculations. Calculations. So now calculations I will export. Okay, so before that, let me remove it. So here again build path. So remove from build path. Okay. So here calculations class I will export. So jar file. Okay, so here from src access modifiers class, I want to share only calculations Java. Okay, so name I'm giving it as calculations. Calculations jar. Okay, so finish it. Okay, no problem. So now you have the calculations jar. You have, so let me delete it. So calculation jar you have. Okay, so let me import that. Let me import that jar to use that. Okay, here I'm deleting this class, calculations class. Okay, delete it because I have already exported to jar file. So now I want to use the calculations jar file. Okay, if you want to use it in the build path, you have to class level path, you have to add that jar file. It is on desktop, calculations jar, open it and apply and close. Okay, in the reference libraries, you can see that calculator class. So now I want to create a object for calculations class. Okay, it is there in the access modifiers. Okay, not in this access modifiers. It is available in the jar file. Package name also it is showing access modifiers. Cal C equals to new calculations. New calculations. Okay, new calculations. Access arithmetic operations from jar or access calculator class from jar. Access calculator from jar. Calculations from jar file. Finish it. No problem. Finish it. Access calculations from jar file. So now if you try to use all these statements in the calculations and you just need to change. Okay, so private we cannot access anyway. Okay, so just change it to anyway these you cannot access, right? See. Okay, so in the jar file, okay, you are able to access the same thing. Again, if you add one more class, new class. So here, extend calculations from jar. The same thing. Okay, so copy, you can access in the extend calculations. So here you don't want to create the object, so you have to create the object for your class, but you have to extend the calculator. Extend the calculator. So change the variable name. Okay, when you export, what are all the things you can provide the access? So here calculations you have to give. Okay, and here also you can give the calculations. So similarly, calculations you have to give the access and calculations. Calculations only, right? So here you should not. Okay, I should not change here. Access calculations. Remove this. This is the calculations class. Use the calculations. So like that, the similar way, how you are accessing, the similar way you are able to access. Suppose if I make the, while exporting, if I make my class as, if I remove the class public before the class, again in jar file also you cannot access. Jar file you cannot get the classes from the jar file. You cannot import also from the jar file. Okay, so based on these concepts, okay, so we will apply these arithmetic operations to our abstraction. Okay, so let me create the, okay, so in the abstract class, what I want to do, what is the abstract class? If you want to share some content, okay, and for the other content I don't want to share, okay, what you can do, so you can create a abstract class. Here you don't want to change few logics. You don't want to change few logics, but you want to give the access to your class. Okay, so here let me create one more class, that is abstract class. Abstract calculations class. Abstract calculations. Finish it. Okay, here what I want to do. So I want to give access to some classes, and for some other classes I don't want to give the access. Okay, so copy same operations from access modifiers. So here let me come to abstract class. So remove this and also remove these classes. Okay, so my class name is, so these packages are not required. My class name is abstract calculations. Abstract calculations. Okay, this is my class. So these also I want to remove, because with the data you can protect with the private keyword. Okay, remove it. Okay, coming to the access of methods. Subtraction, I don't want to give the access. I don't want to give the access for my subtraction. For division also I don't want to give. For division also I don't want to give. So whenever you have more than one, whenever you have at least one incomplete method in your class, at least one incomplete method in your class, that method we call it as abstract method, because there is no logic. This is abstract only. This is abstract only. Whenever you have at least one abstract method, okay, at least one incomplete method, this entire class will be incomplete class. Okay, this is incomplete class because you cannot create the object, because we don't have the complete implementation of your methods. In that case, this entire class becomes abstract class. Okay, so now you have two methods with logic and two methods without logic. Okay, whenever you create any abstract method, most of the time we use these abstract methods as public. Otherwise, there will be no use. Make it as a public. All abstract methods by default public only. Public you have to assign to the abstract methods. So now what I do is, for abstract class, I will create child class name, implement abstract class methods. Implement abstract class methods. I don't want any main method. Here I extend abstract class to implement the. So whenever you want to extend, okay, incomplete class, what you have to do is you have to implement the unimplemented methods, add unimplemented methods. So here, when I do a minus b, it should be a minus b, and this is a by b. Let me remove this public keyword for this. Okay, or what I will do is make it as public. remove public keyword for my class. Okay, now you have some package. You have some package that is abstraction package. That is abstraction package. So inside that you have abstract class. Okay, if you go to abstract class, you can see, okay, only two methods with implementation. Other two methods you don't have the implementation. That implementation you have done in the other class. Okay, that is fine. So now what I do is my abstract calculation class is a public class. So this abstract class I will use into data access package. Here I'm creating one more class, use abstract class. Use abstract class. Create here. If I want to use my abstract class, what I have to do? What I have to do? So either I have to extend or either I have to create the object. So whenever you say, instead of use, what I do is, so let me refactor it, follow the same naming convention, access abstract class, access abstract class. If you want to access abstract class, you no need to extend it. Okay, so when you will extend the class, if you want to add some logic or if you want to override some logic, that time only you have to extend. So here in abstraction, in implementation class, you are overriding the existing methods. That is the reason you are extended. But while you are using, no need to extend. Just simply create the object for your abstract class, abstract calculations, abstract calculations. So here you cannot create the object for your abstract calculations, right? So if you are not able to create the object for your abstract class, what you can do in this case, you can extend. In this case, you can extend your abstract class, or what you can do is, I want to extend implementation abstract class methods. Okay, implementation. Okay, so let me make this also. Okay, so what I do is, if you again extend, you have to implement the methods of your class. So what I do is, so here I will implement the implementation class. Again, for this I have to make it as public. Okay, so let me remove public here, and also if I remove public, I cannot access outside. Okay, so here abstract class. Okay, we have not abstract calculations. So this is public only, not private. This is abstract public. This is also public. Okay. So now implementation abstract class, I want to access in the outside of your class. Okay. In this case, you need to extend implement class. So let me do like this: implementation abstract class methods. Okay. So now you are implementing the abstract class methods, which means it is a class, it is not abstract class. Okay, so now if you create the object for your child class here, so now the hierarchy, how is the hierarchy now? You have to observe here is, how is the hierarchy now? How is the hierarchy? So let's go to illustration, remove this canvas. So here you have calculations, sorry, abstract calculations. Under that, you are implementing abstract calculations and you are accessing calculations. You are accessing calculations. Okay. Abstract class calculations. Okay, I will create one more class. You will understand it. Okay. This is implementation class. Implementation abstract class. Here you are accessing abstract class. Access abstract class. Okay. So here you have these three classes now. So now what I do is, so here implementation class is there, right? This I will remove as public. If I make it as a public, what happens? If I make it as a public, I can access and I can directly access these public methods. Okay, so here I'm creating one more class. Class name is some provide access to abstract class. Provide access to abstract class. Finish it. I don't create anything. Here, I don't create anything. I just extend implementation of abstract class methods. Okay, inside that I don't create anything. Okay, so this is the public class, this is the default class, and this is the abstract class. Okay, so provide access to abstract class. This is a public class. So this class I will extend into my access abstract class methods. I mean access abstract class. Okay, if you create the object, okay, here I have added one more hierarchy. Okay, along with this, I have added one more hierarchy. That is provide access to abstract class. Then we provided the relations. Okay, so from abstract class to abstract class we are extending. Abstract class we are extending. Then we are implementing we are giving the extending the implementation class to provide access. And finally provide access we are extending into some other package. So this is the hierarchy we have created, right? How we can hide our data, I'm explaining. This is the hierarchy I have created. Okay, suppose if we have the hierarchy like this, so if you create the object for your class, if you create an object like this, okay, if you want to assign this child class object to your provide access to abstract class, can you assign directly? You can assign, because this provide access to abstract class is a parent class of access to abstract class, which is a bigger one. Okay, you can perform the upcasting here. Similarly, if you go to provide access to abstract class, here you have a implementation abstract class. Okay, here can you assign to this object? Here you can assign, but this implementation class is there, right? This is not a public class. It is a default class. You cannot access outside the class. So here you cannot access this particular class into any other package. Okay, so this you cannot access now. If you are able to access, you can also assign the child class object. Okay, so for your implementation abstraction class, what is the parent class? Abstract calculations. It is a, let me make it as, okay, so it is a public class, which means you can access, you can import and access it. ABS class equals to, you can access, you can assign this child class object. So before accessing it, just import it. Where it is, import. Okay, abstract class, right? Just simply import that abstract class also, abstract calculations also. See, if you try to import this implementation class, it is not possible. Okay, so let me show you that as well. It is not possible. Suppose if you want to import it, because it is not a public, it is not a public class. You cannot import and you cannot use also. Okay, cannot be imported. Default class cannot be imported. So here you cannot access also. Cannot declare also. Declare default class of other package. Okay. So now for the top level class reference, you can assign the child class object, which means instead of writing the sentence notation, what you can do is, let me put it as one, variable one. You can directly assign the child class object directly. Okay. So now if you want to call any method addition, you can call subtraction. You can call, because your compiler goes to this particular abstract class and it will check these methods are available or not. Subtraction method is also available, division also is available. But coming to the access, you are not giving the access to your actual implementation class. Okay, but you are giving the access to your interface, your abstract class interface, abstract class. Okay, like this you can hide your data. You can give the access to your abstract class and you can access those methods. You can access those methods. Okay, so let me print. Okay, if I call these methods, obviously these methods will be called from where? Okay, so what is this? Arithmetic operation divided by 0. Okay, so here I need to pass 10 and 20. Subtraction 20 and 5. Multiplication 10 and 10. And division 13 by 2. Okay, if you run it, so you are getting the values. Okay, so now you have all your implementation Java files. Okay, if you go to your classes, you are able to see the logic. So let me convert into package. Let me convert into jar. Then you will understand it. Okay. So now what I do is I will export it. Export it as a jar. Okay. So before exporting, so I will give the meaningful names. I will copy these calculations, paste it. Calculations. Okay. So here implementation class also I will copy. Implementation of calculations. Okay, do not confuse calculation implementation. Or let me make it as calculations implementation. Okay, I want to copy provide access. Here, access calculations. Access calculations. Okay, so I have 3 classes. Okay, let me export these. So here jar file, next. So here within this access modifiers abstraction package, I want to access calculations. So remove all these access calculations and calculations implementation. These 3 classes only I want to export. Calculations implementation, calculation, and access calculation. Okay, in access calculation, nothing we did. Okay, so I'm overriding this calculations jar, or let me create calculations, new calculations jar. New calculations jar. Okay, so here the settings you can go and nothing is there. Okay, so here provide access. Let me remove. Okay, 1, 2, 3. Yeah, finish it. Just 5 minutes. I will close this session. 5 minutes. Okay, it is ending. Okay, now I have calculations, new calculations class. Okay, so let me remove one implementation. Sorry, calculation implementation, and also access calculations. Delete it. So let me import the jar. Go to build path, configure build path. So libraries, select class path, add external jar, on desktop, new calculations jar. Apply and close. So now I want to access calculations from the new calculations jar. Okay, so now let me create one class, that is, so here using abstract class, using abstract class from jar. Okay, so now you have jar. Inside that you have abstract classes. If you go to calculations, if you open it, are you able to see anything here? Any logic you are able to see? Yes, you have calculations constructor, you have addition method. It is telling like addition method you have, it is not showing any logic. Here also it is not showing any logic when you create the jar file. And if you go to calculation implementation, here also it is same. You cannot see anything. You cannot see anything. Okay. So similarly in access calculations, nothing is there. Nothing is there in the access calculations. What you can do is So some people might decode also, right? But here to decode the code also, we are not giving the access for your calculation implementation. Okay, if you want to use your abstract class, what you will do is extends the class name is access calculations, or you can do one more thing. Okay, instead of it, what you can do is you can create a object for your new access calculations. Access calculations. It is from the abstraction package. This is your class now, which is there in the jar file. Okay, if you go to this access calculation, nothing is there. See, are you able to see any methods here? Addition, subtraction, or anything is there? Nothing is there, right? Okay, so this, if you want, you can assign to your, you can assign to the same class. Otherwise, what you can do, to the parent class also you can assign, right? Okay, my parent class is, if you want to know the parent class of this access calculations, for this access calculations implementation abstract method is the parent class. Okay, if you go to implementation, sorry, access calculation extending implementation abstract class methods. Okay, I did some wrong thing. So here I did, while creating the jar, I did some wrong thing. Okay, so these I have removed.
ఇంకా చెయ్యలే కదా అది ఈలోపు క్లాస్ అయిపోతే వస్తుంది.
Hello. Okay. So here, so I did some mistake. Okay, in the abstraction. Okay, by mistake, for extending, I have used implementation abstract class methods. I use, instead of it, what I have to do is I have to do the, I have to extend the calculation implementation. But let's see whether it works or not. Let's see. Okay, so using abstract class instead of it. So for this, we have parent class abstract, sorry, calculations class. Calculations. Okay, you are not able to assign the object of your calculations because this is extended by some other class. This is extended by some other class. So which class? Implement abstract class methods. That class is not available now here. Okay, so let me quickly add those classes and I will re-export it. Okay, so this is the calculations. Fine. Okay, let me go to calculations. Okay, this is calculations only. Implementation, just copy it and paste. This is calculations implementation. Okay, after creating this, what I have to do is this one I have to extend from calculations. Okay, so that is the thing I'm mistaken. And also access to calculations. Calculations access. Create it. In the calculations access, I have to implement class or class implementation. What is the name? Calculations implementation. Calculations implementation. Okay, this is the class. Okay, now I have these three classes. Let me quickly export it. Okay, today I'm taking more time. Sorry for that. If I stop in the middle, you will not understand. Okay, here. So my package abstraction. So from here, I want to access only calculations related stuff. Calculations access. Only three classes. So new calculator I will override, the same jar I will override it. So now if you refresh it, if you refresh the project, where is refresh? Yeah, so these are updated now. So in my data access, what I do, so let's remove this. Okay, so here calculations access. So before that, so again let me remove these three from here. Okay, what happened? Remove it. So create the object for your calculation access. Calculation access. It is from the abstraction package. New calculation access. This is fine. Okay, but if you go to this class, so nothing is there. Nothing is there. If you want to call some method, first you have to go to that class and you have to check, right, whether the method is available or not. Blindly you cannot type something and you cannot access, right? Blindly you type something and you cannot access, right? Some method like that you cannot access, right? You will go and check the method in that class. But in this method I don't have any methods. If you go to calculation class, it is implemented by calculation implementation. Okay, so if you want to assign the object to your calculation implementation, okay, here you have methods. Okay, so what are all the methods? Here also it is showing, it is not showing any method. See, if you go to, okay, calculation implementation, if you go to here you can see subtraction method and also division method. Okay, you felt that, okay, in this class you have some methods, you want to use those methods. Okay, you want to use those methods. But if you want to use those methods, so how you have to do? Again, you have to assign the object to calculation implementation. Why I have to assign the calculation implementation, calculation access object to calculation implementation? If you assign like this, your compiler directly goes to this class and it will search for those methods. Your compiler directly goes to this class. That's what we have discussed yesterday. Directly your compiler goes to this particular class and it will search for the methods. But if you try to import this class, okay, this class you are unable to import. Import also is not giving, because it is a default class. You cannot import into any other package. Then you have to go to this class, and what is the parent class you have to check. My parent class is calculations. Okay, again you go to calculations, then you can create a calculations reference. You have to, it is important now. You are able to assign the child class to your calculations. So now you go to calculations class and check what are all the methods you have. Addition you have, multiplication you have. Okay, so similarly, what are all? Addition, multiplication. So you must have these two methods, subtraction and division also. See, subtraction is there. You cannot see any logic under that. And also division also you will have. Okay, very division also you have. So you have some methods to call. For division and subtraction, you cannot see any logic under the methods. So here if you take, for these it is showing something else. But these methods it is not showing anything. But what you can do is, you can call these methods subtraction and multiplication, even though you don't have the logic inside the calculations. You can call subtraction, you can call the subtraction as well as multiplication. Addition and division also you can call. And addition and multiplication also you can call. Any method you can call, because those are available in the calculator abstract class. Okay, for accessing you are not giving, you are not showing, at least minimum logic also you are not showing. Okay, but still you are able to perform the operation. Okay, so if you call with 10, 20, it has some logic in the calculation class. Yes, it will give the access. Coming to subtraction, it doesn't have the access. It doesn't have the logic. If you go to calculations class, so for addition, you have something to decode. But coming to subtraction, under that nothing is there. Coming to multiplication, nothing is there. Sorry, multiplication we have at least something. And if you go to division, nothing is there under that. Okay, to decode also. So like that you can hide your method logic. Hide your method logic and provide the access to your logics. Okay, provide the access to your logics. See, still it is executing all the methods, but you cannot see the logic inside the calculations class. Okay, sometimes you this implementation class also you are unable to see. This they will hide. This they will hide. You can see only calculations and calculations access. In that case, so you have to like create the object for your child class, and for parent reference you have to assign. From the parent class you will call all your methods. The implementation class also you cannot make. So with access modifiers and abstraction, we can hide our logics. We can provide the overview. So this is still partial abstraction only. Okay, if you go to calculations class, here you can see some implementation. Here also you can see some implementation in the form of encoded format, but you cannot see the implementation for subtraction and division. If you don't want to provide this encoded format logic, you want to provide only just overview. Just overview means just method names like this. That also you can do with the full abstraction. Okay, with the full abstraction you can do. With the full abstraction you can do with the help of interfaces. With the help of interfaces you can do the full abstraction. Okay, so full abstraction we will discuss tomorrow. I hope you understood this concept. Okay, how we are performing how we are hiding our data and how we are accessing our data from the abstract classes. So let me stop recording.